In this video, I'm going to go over our first semester review assignment, and this video is made for the assignment that is from 2018-2019. You can check to see if this is your assignment by looking in the top left corner and checking the date. The QR code in the top right will link to my YouTube page with math tutorials that are more in depth than what I'm going to show in this video. For the first few questions, I'm going to pull in a place value chart here, and I'll put that right up here at the top because we're going to need that for several questions in a row. So question number 1 has a number written in word form, and we're trying to translate that to standard form. That number is 854,007,021. So anytime we see numbers written in word form, each of our place value periods are going to be separated by commas. So this first one is the millions place, this is the thousands, and then this would be our units. So I'm going to use the chart to help organize my numbers here. I have 854 in the millions period, 854. Then I have 7,000 in the thousands period, so that means I have no 100,000s, no 10,000s, and 7,000s. And then I have 21 in the ones place or the units place, no hundreds, 1 or 2 tens, and 1 1. I can go back and put commas separating each of the periods. So my answer is 854, comma, 007, comma, 021. That's 854,007,021. Question 2 says write the number 2,605,931 in expanded form. The first thing I'm going to do is I'm going to write that number in the place value chart. So I have 2 in the millions, then 605,931. I can place my commas in the correct places. And when we're writing things in expanded form, we're pulling each of our digits out of the place value chart, and it's saying its full name. So that 2 is in the 1 millions place, so its name will be 2 million. I'm going to add each of my digits up, or write this as a number sentence where I could add all of them up. The 6 is in the 100,000s place, so its value is 600,000. The 0 is in the 10,000s place, but there is nothing in the 10,000s place, so I don't even have to write it. The 5 is in the thousands place. Its value is 5,000. The 9 is in the hundreds place. Its value is 900. The 3 is in the tens place, its value is 30, and then the 1's value is just 1. If we were to add all of that up, we would get our original number, 2,605,931. Question number 3 says write the number 3.09 in word form. I'm going to write that up in my chart, 3.09. When we are writing numbers or saying numbers in word form, we're going to read all of our whole numbers first. And of course, just as we would normally read whole numbers, after each set of 3 digits, we will read the correct place value that goes along with that period of numbers. But in this case, I only have the number 3, so I'm just going to write it out, 3. The decimal point we are going to write as the word and then the decimal part that comes after the decimal point, we're going to read the entire number all together and then say whatever the last place value is. So in this case, we have a 9, so I'll write the word 9. And that 9 is in the hundredths place, so I'll write out the word hundredths. So the number in word form is 3 9/100ths. Question 4 says write the number 84 over 1,000 as a decimal in standard form. So if I were to fill that into the place value chart, the 84 would have to end up in the thousands place. So I'll have it ending in the thousands place. I'll fill in the tenths place with a 0 because there's nothing there. That 0 is just a placeholder. And I'm putting a 0 in the ones place so we can see our decimal. So as a decimal in standard form, this would be 0 84 thousandths. I want to point out that it is necessary to have this 0 right here. If I didn't have that 0 right there, the 8 and the 4 would not be in their correct place values, and we need the 4 to end up in the thousandths place. This leading 0 right here, because there is no whole numbers in this number, is not necessary for me to put there, but it is a convention for us to put that before a number that is less than one whole to make it clear that there is a decimal point in that number. Question 5 says, write the number that is exactly 10,100,000 larger than 46,587,139. First thing I'm going to do is write this number in the place value chart. So 46 goes in the millions period, 587 in the thousands, and then 139, and the units are the ones period. So I'm going to want a new number that is 10,100,000 larger. So I need to find the 10 millions place value, and I'm going to highlight that right here. And I also need to find the hundreds place value, which is right here. To make a number 10 million larger, I just need to add 1 to the 10 millions place, so this will become a 5. And to make a number 100 larger, add 1 to the hundreds place, this will become a 2. I'll rewrite the number. 56,587,239. For question 6, I've pulled in a larger place value chart because I'm going to try to put 5 different decimals in order from least to greatest. So the first thing I'm going to do is write each of these decimals into this chart. My first number is 3 7200ths, so there's 3 ones, then the decimal, and 72 hundredths. Then I have 3 72 thousandths, 3 2 tenths, 3 702 thousandths, and 3 2 hundredths. So before I start comparing these decimals, I'm going to make equivalent decimals by placing zeros in any empty places. So I'm going to put a 0 here, 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 and here. Now all of my numbers have the same amount of digits, and they'll be easier to compare. When I start comparing, I always start with the greatest place value, which is the ones place. I will then compare from left to right, so I'll start right here in the ones place. All these digits are the same, so I'll move to the tenths place. And I see this number right here has a 0 in the tenths place, and so does this one. So these are going to be my 2 smallest numbers. I need to figure out which one of these 2 is smaller though. So I'll move to the hundredths place. This one has a 7 there, this one has a 2, so this number is the smallest, and then this would be the next smallest. I can go ahead and write those down. 3 2 hundredths, and then 3 72 thousandths. So I'm done with these 2 numbers. I'm going to mark them out so they don't get in my way. And now I'm going to keep comparing my other numbers. So I already determined that the ones place was all the same. Moving on to the tenths, I see a 7, a 2, and a 7, so this one's going to be the smallest. So 3 2 tenths. And I'll mark that out as well so it won't get in the way. I'm to my last 2 numbers. 7 in the tenths place, and this number I have a 0 in the thousandths, or in the hundredths, and this one has a 2 in the hundredths, so this one is my next smallest. 3 702 thousandths, and my last one is 3 72 hundredths. So now I've put my numbers in order from least to greatest. Problem 7 asks me to compare 2 numbers using less than, greater than, or equal signs. I'm going to write those 2 numbers in the place value grid. So my first one is 0 30 hundredths. So 0 30 hundredths. My next one is 0 300 thousandths. And if I'm looking at value here, both of these numbers have a 0 in the ones. They both have a 0 in the tenths, a 0 in the hundredths, and they actually both have nothing in the thousandths because I can put a 0 right here and make an equivalent decimal. So these 2 decimals are equal. Part B is 2 76 hundredths and 2 706 thousandths. I'm going to put a 0 right here to make an equivalent decimal so I can easily compare. And I have the same digit in the ones place, same digit in the tenths place, but in the hundredths place, this one is greater. So that makes this number right here greater. So it is greater than. So for problem 8, let me scroll this page up. Problem 8 says, use estimation and comparison to place the following decimals on the number line below. So it looks like the number line starts at 1, ends at 3, so midway would be 2. And then halfway between 1 and 2 is 1.5 or 1 5/10. And halfway between 2 and 3 is 2.5 or 2 5/10. So now that I have some benchmark decimals on the number line, I can start trying to estimate where each of my decimals go. So my first number is 2 3/1000. Because it is greater than 2, it's going to be somewhere in this range on this half of the number line. And it has a 0 in the tenths place and a 0 in the hundredths place. So that tells me if I cover up that 3, that tells me it's just ever so slightly larger than the number 2. So I'm going to try to get it as close as I can to 2. It's going to go right about there, 2 3/1000. The next number is 1 4/10. So it has its whole number place is a 1, so that means it's less than 2. And it is 4 in the tenths place, so that tells me it's less than 1 5/10. If I try to divide this up a little bit more, I can split this into 1 1/10, 1 2/10, 1 3/10, 1 4/10, and then 1 5/10. So it looks like 1 4/10 is going to be right about here. So I'll label that 1 4/10. Next number is 1 83/100. So it starts with 1, so it is on the left-hand side of this number line. Its tenths place digit is an 8, so that tells me, it narrows it down, it's in between 1.5 and 2 wholes. So just like I did previously, I'm going to try to split this up into tenths. So 1 6/10, 1 7/10, 1 8/10, 1 9/10, and then 2 wholes. So now I can go and find 1 8/10, which is right about here. So 1 83/100 is just a tiny bit more than that. If this is 1 9/10, right here would be 1 85/100. So 1 83/100 is going to be right about there. I'll do the best I can to mark that right about there. And that's 1 83/100. The next number is 2 9/10, so it's on the right-hand side. And matter of fact, it's in between 2 5/10 and 3 wholes because it has a 9 in the tenths place. It should be fairly close to 3 wholes, but I'm going to try to divide this up a little bit to help me out. So 2 6/10, 2 7/10, 2 8/10, 2 9/10, and then 3 wholes. So it looks like 2 9/10 is going to be right about here, 2 9/10. And the last one is 2 537,000ths. So it's greater than 2, so it's over here. It's also greater than 2.5. There is a 5 in the tenths place, but if I make the 2.5 an equivalent decimal by placing a couple more zeros right here, I can see that 2 537,000ths is greater than 2 500,000ths. And this right here was 2 6/10 or 2 600,000ths. This would be 2 550,000ths. So 2 537,000ths is somewhere right in that range. So I'll place a mark there and label it 2 537,000ths. Question 9 says shade the given decimal or fraction on each picture below. So part A is 9/10, but I have a 100 square below, so I want it in terms of hundredths. So I'm going to place a 0 in the hundredths place. That gives me 90 hundredths. So that means I need to shade in 90 of these little squares, or 9 columns, 9 groups of 10. So I'm just going to quickly shade in 90 squares, 9 groups of 10 to represent 90 hundredths. Part B says 9 hundredths. So that just means shade in 9 small squares. And part C is now a thousandths square. The large cube is a thousandths cube. So I'm trying to shade in 9 thousandths, which just means shade in 9 of these small cubes, 9 thousandths. All right, question 10, and let me scroll up just a little bit. It says, write the letter that best represents 4/10 on the number line below. So I'm going to change 1/2 to 0 and 5/10, because 5/10 is the decimal equivalent for 1/2. So that makes this a fairly easy problem because 4/10 is smaller than 5/10. So the only one that would make sense would be A as 4/10. So the answer is A. Now if I look at each of these other points, if this amount right here is the difference between 4/10 and 5/10, that means that's 1/10. It appears that that's the same distance right here. So that would make B 6/10. So this would be about 7/10 right about there, 8/10 right about there, and that looks like the C would then be 9/10. So there's another 10/10, 11/10, 12/10, and it looks like D might be even 1 and 25/100ths or 1 and 1/4. It's possible it could be 1 and 3/10 as well. Question 11 says write the decimal that's exactly halfway between 3 and 5/100ths and 3 and 6/100ths. So I'm going to make equivalent decimals here by placing a 0 in the thousandths place. And now I just need to figure out what's exactly halfway between 3 and 50 thousandths and 3 and 60 thousandths. And it looks like that's going to be 55. And then I can fill in everything else. So my answer is 3 and 55 thousandths. Number 12 says list all the factors of 36. Factors are pairs of numbers that can be multiplied to equal a number. So the factors of 36 are 1 and 36. They're partnered together. 2 and 18. 3 and 12. 4 and 9. And then 6 is partnered with itself because 36 is a square number. 6 times 6 is 36. On 13 and 14, I'm going to do a factor tree to find the prime factorization. So I'm going to split 63 up into 2 of its factors, and I can think of 9 times 7 is 63. 7 is a prime number, so I'm going to circle it. 9 is not. 3 times 3 is 9, and both the 3's are prime. So the prime factorization is 3 times 3 times 7 equals 63. I could also write that as 3 squared times 7 equals 63. Number 14, 12 times 10 is 120. And there are other ways you could do that. You could have done 60 times 2 or 40 times 3. But 12 times 10 is the one that came to my mind first. Neither of those are prime, so I'm going to split them both up. 4 times 3 is 12. And again, you could have done 6 times 2. 5 times 2 is 10. 2 is prime, 5 is prime, and 3 is prime. 4 is not. So 2 times 2 is 4, and then both of those 2's are prime. When I write the prime factorization, I'm going to group like prime factors together. So I have 3 2's, a 3, and a 5 that are circled. If I multiply that out, 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And 24 times 5 does equal 120. With exponents, I could write this as 2 to the third power times 3 times 5 equals 120. Question 15, and I'm going to scroll up a little bit. Question 15 is evaluate 27 times 10 to the third power. So 10 to the third power means 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. So my problem then becomes 27 times 1,000. So that's 27 with 3 tens, 27,000. Question 16. The base problem is 5 times 8. 5 times 8 is 40. And I have 1, 2, 3, 4, 5 more tens that need to be multiplied in there. So 1, 2, 3, 4, 5 tens and a comma every 3 digits. So my answer is 4 million. Number 17, I have blank times 30 is 21,000. So I'm thinking, what number times 3 is 21? That number would be 7. And then I have 110 in my problem here, and I have 3 in my solution. So I need 2 more 10s, so everything balances out. On number 18, 4 times blank equals 12. 4 times 3 equals 12. I have 2 10s in the problem. I have 1, 2, 3, 4 in the solution, so I need 2 more to balance my equation. I'm going to scroll up a little here for numbers 19 and 20. Numbers 19 and 20 look like they are partial products, which is using the distributive property to multiply numbers. So on number 19, we already have an area model set up for the problem. So this first box, this box right here, is going to be the factors 60 times 30. So 60 times 30, that equals 18 with 2 10s. The next box to the right is 30 times 4. So that's 3 times 4 is 12 with 1 10. The box on the bottom left is 8 times 60. 8 times 6 is 48 with 1 10 in the 60. And the last box is 8 times 4, which is 32. So now I just need to add up each of the partial products. And I'll have my solution. 2 and nothing is 2. 8, 2, and 3 is 13. Carry the 1. 8 and 4 is 12. Plus 2 more is 14. Carry the 1. And we have a final answer of 2,432. On problem 20, the area model is not set up, so I'm going to have to set it up myself. So I'm going to write 384 in expanded form. The 3 is worth 300. The 8 is worth 80. The 4 is worth 4. In 27, the 2 is worth 20, and the 7 is worth 7. If I multiply each of my partial products out, so this first box right here on the side is 20, on the top is 300. So it'll be 20 times 300. 2 times 3 is 6 with 3 10s. The next box to the right is 20 times 80. 2 times 8 is 16 with 2 10s. Next box to the right is 20 times 4. 2 times 4 is 8 with 1 10. If I go to the bottom left, I have 7 times 300. 7 times 3 is 21 with 2 10s. Then I have 7 times 80. 7 times 8 is 56 with 1 10. And then I have 7 times 4, which is 28. Again, adding all of these partial products up, it doesn't really matter what order that I add them in, because the associative property of addition says I can group them however I choose. So 8 plus nothing is 8. 6 and 2 is also 8. 6, 5, and 1 is 12. Carry the 1. 6 and 2 is 8 plus 2 more is 10. So I have an answer of 10,288. I'm going to scroll up for these problems. So 21 and 22 both ask me to estimate and then solve. When I'm multiplying, I always round to the greatest place value. So I'm going to round this to 90. And I'm going to round this to the greatest place value is the hundredths place. That's closest to 500. So my number model would be 90 times 500 is 45 with 3 10s, 45,000. Now I'm going to do the actual problem. I'm going to do this one with traditional multiplication. With traditional multiplication, I look for whichever factor has the greatest number of digits, which is 467. I put it on top. And I line up my other factor with the right-hand side. And now I'm doing 7 times 3 is 21, carry the 2. 6 times 3 is 18, plus those 2 is 20, carry the 2. 4 times 3 is 12, plus those 2 is 14. I'm done with the 3, so I'll place a 0 here. 9 times 7 is 63, carry the 6. 9 times 6 is 54, plus those 6 more is 60. Carry the 6. And 9 times 4 is 36, plus those 6 more is 42. Add up these partial products, and I get 43,431. I'm going to compare that to my estimate right here, and they're fairly close, so my answer is reasonable. On number 22, I'm going to round 54 to 50 and 39 to 40. So my number model is 50 times 40. 5 times 4 is 20 with 2 more 10s. So my estimate is approximately 2,000. I'm going to do this one with lattice multiplication. So I'm going to write my numbers first, 54 and 39. Then I'm going to draw a box inside of here, split up place values, and connect top right, bottom left of every box. In the top left, I have 5 times 3, which is 15. The top right, I have 4 times 3 is 12. Bottom left is 5 times 9, which is 45. Bottom right is 4 times 9 is 36. And I will now add diagonally. 6 and nothing is 6. 5, 3, and 2, that is 10, carry the 1. 5, 4, and 1 is 10, plus that 1 more is 11, carry the 1. 1 and 1 is 2. I have an answer of 2,106, and compared to my estimate, it's pretty close, so another reasonable answer. Question 23. I'm going to zoom in here. It says estimate 457 and 5/10 plus 2 and 7/100. So there's several ways that you can do this. But when I'm rounding with addition or subtraction, I'm looking for things that I could quickly do in my head. And I think I can round this to 458 to the nearest 1, and then also round this to the nearest 1, which would be 2, because I can do that in my head and get 460. But I could round this, for the 457 and 5/10, I could round that to 460, and then the 2 and 7/100 to 2 and get 462. Question 24. I have 1,598 and then just a little bit more. I'm going to round that to 1,600. And then the 39 and 2/10 I'm going to round up to 40, because I can do this in my head. 1,600 minus 40 equals 1,560. If you wanted to round each number to the nearest whole, you could have done this as 1,598 minus 39, but that's a little bit more tricky to do in your head. You get 1,559. Number 25 says round 52 and 381 thousandths to the nearest 10th. This right here is the 10ths place, and the 8 to the right of it tells me that I'm going to round up. So this is going to become 52 and 4/10. On number 26, it says round 2 and 56/100 to the nearest whole. Here's the whole number place value, and the 5 to the right of it also tells me I'm going to round up. So to the nearest whole, this is 3 wholes. Remember that when you're rounding, you're thinking of this as a big hill. We have 2 over here, 3 wholes over here, 2.5 right in the middle, and 2 and 56/100 was right about here. So if this was a big bowling ball, it would roll all the way down the hill to the 3. I'm going to correct a mistake in the directions on the next one. This should say questions 27 and 28. Ask me to model each operation using the decimal squares. So I'm going to use 2 different colors for these. The first one I'm going to do is model 51/100. That's 5/10 and 1/100. So 1, 2, 3, 4, 5/10 plus 1/100. And then a different color, I'm going to do 6/10 plus 3/100. So when I do 6/10, this is 9 plus 1, that's 1/10, 2/10, 3/10, 4/10, 5/10, and 6/10 plus 3 more hundredths, 1, 2, 3. So now I just need to look at what I have here modeled with my decimal squares, and I see 1 whole square right here, and then I see this is 1/10, And then this last part right here is 4 hundredths. So I have 1 whole, 1/10, 4 hundredths, 1 and 14 hundredths. 28, the first thing I'll do is model 1 and 93 hundredths. So I'm going to go ahead and shade in this entire whole, 1 whole, and then I want 93 hundredths. So 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths, and 3 hundredths. 1, 2, 3. In a different color, I now need to shade 1 whole and 73 hundredths. I'm going to go ahead and just shade in this entire whole here. And then I'll shade in my 73 hundredths. So right here, this is 7 hundredths, so I need 3 more to make 1/10. So there's 1/10 plus 3 more is 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths plus 3 more hundredths. 1, 2, 3. And now I just need to see what's modeled here. I have 1 whole, 1 whole, 1 whole. I have, what is that, 6 tenths. And then 1, 2, 3, 4, 5, 6 hundredths. So I see altogether 3 wholes, 6 tenths, 6 hundredths, 3 and 66 hundredths. All right, let me scroll up for 29 and 30. 29 and 30 just ask me to do the operations. So anytime when I am adding or subtracting decimals, I must line up place values. So the first thing I'm going to do is find the ones place. There's the ones place. It's always to the left of the decimal. And here, this is the ones place. The decimal is just to the right of that. Remember that decimals do not move. You may not change where the decimals are. You just need to discover where they are. So I'm now going to line up my decimals and fill in any empty place values with zeros. Now I can go ahead and add. 4 and 0 is 4. There's my decimal point. 8 and 7 is 15. Carry the 1. 5, 1 and 1 is 7. So I have 75 and 4 tenths. Number 30. Here's the ones place. Here's the ones place. I have 32 and 38 thousandths and 3 and 72 hundredths. Notice that my ones places are all lined up right here. Fill in any empty place values and add. 8 and 0 is 8. 3 and 2 is 5. 7 and nothing is 7. 3 and 2 is 5. And 3 and nothing is 3. 35 and 758 thousandths. Number 31. Here is the ones place, and here is the ones place. The decimal always comes right after the ones place. So my number that I'm doing the operation to is 82 and 36 hundredths. I'm subtracting 17. So again, my ones places are lined up. The 2 and the 7 are lined up. Filling in empty place values and subtracting. 6 minus nothing, 3 minus nothing. Can't do 2 minus 7, so I'm going to have to regroup. 12 minus 7 is 5, and 7 minus 1 is 6. 65 and 36 hundredths. Number 32. The ones place is this 5, and then the 0 here. Decimal always comes right after the ones place. The number I'm doing the operation to is 1,000. The last 0 before the decimal is lined up with the 5 that's also in the ones place. Fill in any empty place values with zeros and subtract. And obviously I'm going to have to do quite a bit of regrouping here. This 1 becomes a 0. These all become 9s, and then the last one will become a 10. 10 minus 9 is 1, and then I have a couple of zeros, a 4, a 9, and 9. So I have 994 and 1,000th. And if you just kind of think about that problem, 5 and 999 thousandths is really close to 6. So if I subtracted 6, which you could probably do in your head, you would have gotten 994. But 5 and 999 thousandths is 1,000th less than 6. So I need to add 1,000th back. So my answer makes sense. I'm going to scroll up again for number 33 and 34. It says solve using extended division facts. So I'm going to do 42 divided by 7, which is 6. These zeros represent tens. 10 divided by 10 is 1, so that cancels out. And 10 divided by 10 is 1. That cancels out, so I have a final answer of 6. Can always go backwards and check. 6 times 700 should be equal to 4,200. 42 with 1, 2 tens, it is. Question 34, 24 divided by 8 is 3. 10 divided by 10 is 1. And I have 2 tens that are not canceled out. So my answer is 300. I can check that. 300 times 80 should be equal to 24,000. 3 times 8 is 24. 1, 2, 3 tens. 1, 2, 3 tens, 24,000. Questions 35 and 36 are division, and they ask me to estimate and solve. When I'm doing estimation with division, I always start with the divisor, and I look at it and see if I can leave it alone. And if I leave 6 alone, this is going to require me to know my division facts past 6 times 12, because 6 times 12 is 72, and if I uncover the first 2 digits, that's 83. So I can either keep going by 6 times 12, and I can out to the side say 6 times 12 is 12 sixes is 72, 13 sixes is then 78, and 14 sixes is 84, which is really close to 83. And I can change that to 84, and then the 1 and the 4 will change to a 0, so I have an extended division fact. And then I can do 84 divided by 6 is 14, and I have those 2 tens that aren't canceled out, so I have an estimate of 1,400. Or I could have rounded the 6 all the way up to 10, and then rounded the 83 to 80. That would again give me an extended division fact. The 1 and the 4 will again become zeros. 80 divided by 10 is 8. And then I have 2 zeros that are tens that are not canceled out. So I have an estimate of 800. And lastly, I also could have rounded that 6 to an 8. And then looked for a multiple of 8 that was close to 83, which would be 80. The 1 and the 4 will change to zeros. And 80 divided by 8 is 10. And then I have these 2 zeros right here that are not canceled out. So in all 3 circumstances, my estimates are between 800 and 1,400, so I should get an answer that's somewhere in that range. So to do the actual problem, 8,314 divided by 6. 6 goes into 8 one time. Multiply that out, and then subtract, and I have 2 leftovers that I'll regroup with this 3. 6 goes into 23 3 times, and subtract, and then regroup. 6 goes into 51 8 times. Subtract and regroup. And 6 goes into 34 5 times. And it looks like I have a remainder of 4. I'm going to write my remainder as a fraction, so I'm going to write 4 over 6. So I have an actual answer of 1,385 and 4/6. And if I compare that to these estimates right here, it's in the range of 800 to 1,400. Problem 34, I'm going to leave the 4 alone. Look for a multiple of 4, something that's in the 4 fact family that's close to the first 2 digits that's 40. 40 is in the fact family of 4, so I'll leave it alone. The 3 and the 2 will change to zeros, and I have an extended division fact. 40 divided by 4 is 10, and then I have 2 zeros that I'll put on the end. So my estimate is 1,000, the actual problem. 4 goes into 4 one time. When I regroup right here, 4 does not go into 0, so I must put a 0 in the quotient. Then I can regroup again. But 4 does not go into 3 either, so I must put another 0 in the quotient and regroup. 4 goes into 32 8 times, and I have no remainder. Compare to my estimate, and it is very close. Question 37 and 38. Question 37 says Union 5th graders attended a music recruitment concert in December. If there are 1,173 5th graders and a bus can hold 45 students, how many buses will be needed for the field trip? So I need to take my 1,173 students, and I need to group them into groups of 45. And that eventually is going to tell me how many groups of students I can have, and each of those groups of students will represent how many buses that I need. So if you don't know your multiples of 45, you'll either want to do some side multiplication here, or do a little mini multiplication chart off to the side. But I'm going to go ahead and start the problem. 45 does not go into 1. It also does not go into 11, but it does go into 117. I'm going to do a little multiplication table. 1 45 is 45, 2 45s is 90, 3 45s is 135. So 45 will only go into 117 twice, and that uses up 90 students. So I have 27 leftovers that I'll then regroup. So now I am at 273. I need to extend my mini multiplication table, so I'm going to add another 45 here, and that gives me 180. 5 45s is equal to 225. 6 45s is equal to 270. And I'm really close to 273. Obviously, one more 45 would be too much. So I need a 6 there. 6 times 45 is 270. Now I have 3 students who are left over, and I know these are students because I started with students. Those 3 students need to be on a bus. So instead of 26 buses, I need 27 buses. 38 says GameStop is selling video games for $6 each. If Levi has $34, how many video games can he buy? So I'm trying to divide my $34 into equal groups of 6. And because all I want to know is how many video games I can buy, I do not want a dollar answer. I don't even need to write my $34 with dollars and cents. So I can just write it out like this: 34 divided by 6. 6 does not go into 3, it goes into 34 5 times with 4 leftovers. And this 34 was dollars, so I have $4 left. And these are 5 games that I can buy. If I have $4 left, that's not enough to buy a game, so I can only buy 5 video games. I'm going to scroll up for question 39. It says use the data set below to find each landmark. And I'm going to start with the mean. The mean is the leveling out point of data. And if I think of each of these numbers as test scores, I have 1, 2, 3, 4, 5, 6, 7 test scores here. If I combine all of those points that I got on the tests and then divide by my 7 scores, I'll get a leveling out point of an average score. So I need to add up each of those scores: 74, 90, 85, 100, another 85, 46, and 80. And I'm going to use the associative property here to group things. So I have 6 and 4 is 10. 5 and 5 is also 10, so I have 20 there. Carry the 2. And let's see, I have 8 and 8 is 16, plus this 4 is 20. 20 and 8 is 28. 28 and 2 is 30. 30 and 9 is 39. And then plus the last 7 is 46. Carry the 4. And then 4 and 1 is 5. So I have, altogether, I have 560 points that I'm trying to share equally among my 7 test scores. 7 does not go into 5, but it goes into 56 8 times. And when I regroup, 7 does not go into 0, so I have a mean or an average score of 80. The median of numbers is the middle of a set of numbers, so the first thing that I'm going to need to do is put my numbers in order from least to greatest. So I see the smallest number, the minimum is 46, and then I have a 74, then an 80, and an 85, another 85, a 90, and finally 100. I'm trying to find what number would be in the middle, so I'm going to mark out the smallest and the largest, the smallest and the largest, the smallest and the largest, and I'm left with the median, 85. The mode of data is the most frequently occurring number, so I'm just going to look at my data and figure out what number I see the most of, and the number I see the most of is 85. And the range of data is the difference between the maximum and the minimum. I want to know how far apart the maximum and minimum are. So here's the maximum, 100. Here's the minimum, 46. To find that, I need to subtract 100 minus 46. Do some regrouping here, and I get 54. Let me scroll up one more time. It says, give an example of each property of addition and multiplication. The commutative property is basically turnaround facts. It says that the order that we add or multiply numbers will not affect their sum or product. So I could write this with numbers like 4 plus 5 equals 5 plus 4. 4 times 5 equals 5 times 4. I could even use variables. A plus B equals B plus A. A times B equals B times A. The associative property is the grouping property. It says that I can group numbers in different ways and it won't affect their sum or product. So I could say 4 plus 5 plus 6 and group it this way. It's the same thing as doing 4 plus 5 plus 6 and grouping it this way. Same thing with multiplication. 4 times 5 times 6, grouping this way, is equivalent to doing 4 times 5 times 6 and grouping this way. And the identity property says that when I take a number that I'm going to call A, and if I add 0, I end up with A. I could also take that number A, I could multiply by 1, that will also leave me with A. And the last problem says use the distributive property to simplify 2 times the quantity x plus 5. The distributive property says that I'm going to multiply everything in the parentheses by the 2. So let me rewrite this. If I have 2 times the quantity x plus 5, that means I'm going to do 2 x's and 2 5's. 2 x's would be 2x, and 2 5's would be 10. So my answer is 2x plus 10. We could have also thought of this as x plus 5 twice. X plus 5, x plus 5. Altogether, that gives me 2 x's and 2 5's, 10.